Hello everyone, I'm here again with another new function which is called the delta function. What is called a delta function? Okay, so I'm gonna explain today what is the delta function, a time domain function, right? Delta function, and delta function is represented by this, and where only you can get a single spike, a single value at 0. Okay, so where the amplitude could be anything. It can be 1, 2, 3, 4, 5, or infinity. You will get that value only where the time is 0. I mean, you will get the value only at 0. Okay, and you will get the value output value 0 at everywhere. I mean, otherwise. Okay, so you will get a single value at 0, and you will get 0 everywhere. Okay, so that is called the delta function, and how it is looks like, how is the graphical representation of that function. We'll explain this. Time here and the x-axis, and in the y-axis there is a value, and you can see you have the only output a, and which is at 0, and you can get only the value at 0. So here is the time t is equals to 0 here, right? This is the origin, and only you will get the output value here, and that is just a spike. It looks like a spike, okay? It looks like a spike which is situated at the time 0, okay? So that is why this is called the delta function, and where we will get a single spike, a single value, and this is called the delta function. But there is not any way to get a single value, and we can say the amplitude is a here, and we're just putting a here because the value of this amplitude is just a. We're representing that. And isn't there any way to get this value at further times? Yeah, definitely you will get, and that is called time shifting. Okay, if function represents that, and you just shifted this impulse here at 1, t is equals to 1, and that was at t is equals to 0. Okay, you just shifted this signal to this. Okay, you just shifted this impulse to this. Okay, this is called also as the impulse. This is also called the impulse. Okay, and also called the delta function. So you can shift this from this to this. Okay, on that time this is also the delta function, but this is the time shifting. We can say, we can write this as the time shifting. Okay, we shifted the value from 0 to 1. If you see it, you can write this impulsive figure into the into mathematical term. You can write this, and this is definitely a time domain function, right? So x of t, we can represent it as x of t. X of t is equals to, you can write, you can see there is an impulse here at t at 0. So delta of t, you can write. And the amplitude is, it represents there is a value at t equals to 0. Okay. And now you are going to use, there is at t equals to 1, right? T is equals to 1, where the amplitude is 2a, right? So I'm just giving the amplitude 2a, and delta of t minus 1, right? T minus 1 because it just shifted. And then I can write again it a into delta of t minus 2, right? You can write this. And we just finish this, and then 3. So we can write again plus 2a times delta of t minus 3 plus, it is 3a. So 3a times delta of t minus 4, right? You can write this. And for this also, plus a into delta of t minus 5. Okay, so you can write this figure you can write in this way. In this term, there's called the impulse or the delta function. You can use delta function to represent this graph or this digital impulse. Okay, so yeah, that was all about the delta function. Thank you very much.